Okay, now we're gonna scrutinize the FEM workbench even more. Let us do some more complicated simulations. I have opened again the Freecad and starting a new part. So let's try to see what we can do if we do something like a part, or instead of the part, let's start with a part design. So as you know, in a part design, we can do a more complicated structure. For example, if I create the body, first of all, I can do a sketch and then I can use extrude. So I'm gonna use, for example, YZ plane, and then, right, so on this plane. So let's do something. I mean, the dimensions doesn't matter at the moment because we are not really having a technical application here in mind, but in order to see that what we can do here, so let us use a polyline again, because I kind of like this polyline, so it makes easier or simpler to do a structure. So I'm gonna make a vertical line here and something like that. For example, I have something in mind where you can use like a shelf you can have on the wall. So let's do something like this, and maybe here a corner. Okay, let's think something like that. I couldn't do that actually. So I want to choose this one and then get rid of it, and then try to make a better line here from that one by using snap to that one. Okay, that's good enough. So more or less that's what I want to have. Of course I can play around with whole dimensions, but let's say that's it. So now I can use an extrude, or technically speaking pad, what they're calling. So I'm gonna make it larger, maybe something like that, and I can even make for example a hole on that. So in order to make a hole on it, so I need to go to model and searching the pad. So I want to have one surface, for example this surface, and on the surface I want to create a sketch. So what I want to have is a hole, so I need to have circular stuff here. It's a rectangular polygon. So where do I have something circular stuff? I don't see it here. That one is the circle. Okay, then I create a circle here, and yeah, I don't like the direction actually. I want to try to move it a bit here, maybe something like that. Yeah, that looks better. Again, normally I should use here a lot of dimensioning, like seeing the distances from left to right and so on, but here I just want to make it quick. And in order to make a hole in it, so I can choose a hole, and as you see it automatically goes through. So of course I can make different way of doing it, like not a hole but just saying like this is like not going through, but here if I choose the hole then it goes through the whole structure. Okay, so now I have a hole here, and then I can even make another hole. Okay, that's right, and choose here, for example I can have another sketch, and let's do something similar. It can be at the same size or not, doesn't matter. So let me move it here, and then even make a hole that it goes through, or I can also say pocket, so that means it doesn't go through, but I can choose how much it is going through. Okay, so of course here as well, if I make it larger, then it will eventually go through. Okay, so it's a hole. So it depends on me. Let's make it fancy. Let's think this is like a smaller one. This is like a pin that you want to put on a pin and then do some forces on that. Okay, let's assume this is our body, so maybe we're happy with that. And now I want to apply on this body an FEM. So that's my purpose here. Because of that I'm changing to the workbench or module FEM, and here now I have on the model, so that's the whole body. And in order to start an FEM we need to start an analysis. So I'm clicking on analysis and then choosing a material for this part. So of course I can choose from the existing materials, or I can put the numbers on my own. Let's use, for example, a wood. And as you know, we have the Young's modulus and Poisson's ratio, because what we are going to do here is a static analysis. So let's use them. And what we want to have is on this analysis, now we have the solver and also material. What we want to have is a mesh. So I need to choose, in order to go to the mesh, so you see here, these are the icons of the mesh, or I can go on top on the mesh, and these are grayed out. That means I cannot select them. So this is why, because I have chosen here the analysis. If I go to the body, if I choose the body, all of a sudden these icons are there. Or if I go to a mesh, then you see these icons are selectable. So I'm gonna choose Gmesh here. So I can of course say 3-dimensional, or I can leave it as from shape. I can use first gradient or second gradient, and I can of course just say apply, and it will use a really coarse mesh. So that's possible, but I want to have a little bit of better one. So technically speaking, I don't know the dimensions, so I'm just using 10. Okay, it's not good enough, so I'm gonna make 5. So that's the maximum element size. That's making smaller, and I can make like 2. Probably that's gonna be fine enough. Okay, so that looks alright. Okay, so I'm gonna use this mesh, and we will later on discuss, of course, about the question about like, is this mesh a good mesh, right? So how do I know that this mesh is a good mesh? How do I know that this fineness that I have chosen, the amount of elements that I have chosen, are good enough? Okay, we will come to that later on. So that's good enough. I'm saying okay, and now we have the mesh and the material, everything is there. So what we need to have is some loading conditions, right? So I need to say where it is fixed and where there are some forces on it. For example, because we have here really nice pin hole and a through hole, so I can really use these ones. So let's assume that this one is fixed. Okay, let's assume here it's a little bit yeah, here it's better. So this inside no, I want to choose only the inside. That one is fixed. Or I can choose that one is fixed. Maybe it makes more sense. Okay, so adding this one. So this is fixed. It doesn't look really nice, but actually it tries to visualize it in such a way that this internal surface here of the hole is somehow fixed. Okay, and that's okay. That's good enough. And then I want to use some forces on this surface. So in order to do that, I need to choose the force. So here's a force, and choosing like the surface. And I also need to choose a direction. So in order to choose the direction, first I need to select the edge and then say the direction. Couldn't do that. First, let me do again. So difficulties to select it. Add. Okay, now I have added. Now it shows me a direction. So now I can change the direction if I want. And now I need to choose the line and then choose direction. Okay, let me choose that one. Okay, now it's working. So see, I can choose a direction by choosing a line, and along this line you will have the forces. I mean, it is only visualized a couple of forces, but the whole surface we have selected, on the whole surface these forces are applied. And of course the magnitude of these forces, let's use like 100 Newton. Okay, so it's wood, so will not carry too much. Technically speaking, we have done everything. Now what we can do is we can go into the solver, and the type of the solver is static. I can say write the input file. I can have a look in the input file. I don't have to, and I can say start Calculix. So pretty much we have done and everything. Now what we want to see is the results. and for example displacement. So now we see the displacement. In order to show the displacement a bit better, I can use here the show and then try to maximize, like factorizing 100 times. Of course we have used some forces here. This is bending in a way, because more or less I did a symmetric part, so this is only bending in one direction. This is fixed and this is bending. We can ask a more educated question about and say, okay, what are the von Mises stresses? Now we see the distribution here, so I'm gonna get rid of this show, and we see the distribution here, and we see here also the minimum and maximum numbers. So 3600 kilopascal, so this is around 3.6 megapascal. So the type of wood that we have, it depends on, of course, are you using oak, are you using timber, what kind of wood material you use. So if we have this technical detail, then we can also know the maximum stress which is allowed in this material, and then we can say, yeah, maybe this is too much or so. Then we can change the design or change the force. So we have seen a bit more sophisticated structure. As you can immediately understand, it doesn't matter for the FEM calculation what we do here, how we do it, doesn't matter at all if the geometry is a simple beam or more sophisticated. The procedure that we have to use is always the same. We need to have the topology, which is the geometry, the CAD design. Then we need to have the mesh, boundary conditions, the material properties, and also the type of the solver that we want to solve, which kind of system we want to solve. And if everything is put into the analysis, Freecad is giving us a really nice and simple graphical user interface to do all the job. For way more complicated stuff, we need to deviate from Freecad and use something else. We will come to that in the next video.